Okay, one of the most important element in the control system is actually a block diagram. Okay, basically a control system consists of subsystem and processes that are very much interconnected, and this subsystem and processes, they are arranged, they are connected to form a complete control system. So there are three basically main characteristic of any standard block diagrams, which are the fundamental blocks, the component of the subsystem, and of course the signal that connects from one block to another. Okay, this is example of fundamental block. Basically, you will have a typical block. In this case, the green square box. These are the components of the subsystem, which have signal in the input as well as signal at the output. Okay, this green box basically represent components of subsystem such as controller and amplifier. Okay, this is one of the example. Okay, you can have this green box or subsystem taking the role of controller, or taking the role of amplifier, or any other process. Okay, each block here, the green box may have one or more inputs, and for example, here we have two green box. The first green box there basically is a subcomponents of subsystem called a valve. So the valve basically receives signal, input signal in terms of voltage, how many volts, and then basically the valve will produce output in the kind of displacement information. Okay, so meaning that the input may be in volts, and the output may be in millimeters, for example. All right. And the next example, there is a motor. So motor also receive input signal in the form of voltage, and of course giving out output signal in a kind of speed, or the RPM. Okay, so components number two basically for block diagram is component of subsystem. Okay, the first one you have here is a summing junction. So summing junction basically allows two or more signal to be added or subtracted. The plus and minus sign has to be written. That indicates basically the signal is added or subtracted following the equation of that summing junction. If you can see, V is equal to V1 minus V2, because that's the sign. If V2 is coming into the plus sign, then you will have V equal to V1 plus V2. All right. So this is summing junction. Next, you have a takeoff point. Takeoff point basically allows the signal to be taken away from components or any output, with the assumption that the takeoff point does not load any system or subcomponent. Okay, and then the example of component of subsystem, you can have controllers, you can have actuators, sensors, and amplifiers. All right, and then number three is you have signal in control system. Okay, so what these three elements basically make up the complete block diagram. All right, we have seen just now the fundamental block. Okay, now we are looking at the subsystem, summing junction, and the takeoff point. You can see more variation of component of subsystem. This is just an example. And then you have signal from the control system. For example, you have input, reference, you have output, error, feedback, disturbance, noise, and many others. All right. This is, for example, one big green box, one fundamental block. You have input taking the signal of R of S, and then giving out the output signal here it is written C of S. So R of S and C of S is basically input and output signal, which categorized in this components of number 3 for any block diagram system. All right, now we are looking basically at the concept of open loop and closed loop system. So the main characteristic of any open loop system is that the output signal of the whole of the total block diagram is not being taken back to the previous block, or the feedback is not there. It is the output signal is not being used as an input to the previous block, for example. So this is the main characteristic of any open loop system. Okay. Okay, it says that the control action of any open loop system depends only on the input. All right, so there is no other element that can influence the operation or the behavior of the system except for the input. All right, open loop system is not capable of filtering disturbances or noise because they just read the input and nothing else. For example, here you have your toaster, your washing machine, and many other examples. So this is the system. Basically, you push one button, they will do what they do until they reach to the end condition. They will stop there. They will not, while doing the process, they will not read from any other signal, from any other influence. They just, after you push the button, they will just finish the operation just like that. So open loop system here is basically suitable when just when you don't need any other influence, when basically you don't need to consider any other influence to your system. All you need is basically a quick start button and the system will finish the operation. Okay, the advantage is simple and very cheap because as I mentioned, the system or the control system just start from the on button. They will finish everything and stop when the process finish, and that's all. All right, so different from a closed loop system. For a closed loop system, you will have a feedback line. For example, here in this case, you will have at the end, you have the output, then you have a takeoff point returning back to the summing junction, which go to the output transducer. Okay, if you look at the closed loop system, you will have the input going process after process, and basically you will end in the output, and nothing is being taken back. Okay, if you look at this block diagram, yes, you have something going back. So this is the main character of a closed loop system. Okay, so the advantage is basically the ability to compensate or filter disturbances, because basically the output is being taken back, meaning that if the output is not not as you expected, you can tell the previous block diagram to change the process, to improve the process, so that you get the desired output, for example. Okay, and the closed loop system basically not sensitive to noise or changes to the system, because all the parameters that may influence the control system is basically taken into consideration and being calculated, meaning that the system basically correct itself by using the feedback signal. And in case if the system is exposed to any kind of external noise or the environmental disturbance, basically the system will adjust itself because they have feedback signal basically. Okay, for example, here we have a washing machine. You can see washing machine, you have two process that involve filling the tank with water and then wash and rinse. So filling the tank with water is basically a closed loop system because you know, the system keep on monitoring the water level until the water level stop. Then you know, the filling operation, the water filling operation will be stopped. So the water you have you know, sensors that read the water level as an input. So this input goes to you know, a control block, a process that you know, compare the water level which the desired one. Then you have output is basically the current level. So once the output of the current level of the what they call that water level is being feedback, so that you know, the system makes comparison uh, just in case the current water level already reached the maximum. So the feedback things is keep on going until the water is you know, full. And then the wash and rinse process is basically an open loop, because you know, this process just start and run, continue the operation without considering anything. You know, you just go straight, wash and rinse until the whole cycle complete, and the system just stop. So this is some kind of open loop where the system doesn't care about anything. You know, just start and finish. All right. So the next thing that we will be looking at is basically transfer function. Transfer function basically represents the system in the block diagram which relates its input to the output. All right. So example, here you have ordinary differential equation, ODE, you know, representing a generic kind of transfer function. Okay. So this is some kind of basic introduction of how do we work with the transfer function in the control system. As you can see here, you have information on the A side and on the B side, everything is in the time domain. All right. So if you have a control system, you know, with a lot of orders, this equation is going to be very, very long. And what normally we do is basically we transform the equation into the Laplace domain. For example, in this case, the whole equation can be simply represented by f of s. So in the Laplace domain, you can the s is basically represented by the alpha plus j omega. So the whole equation of this I would say frequency domain transformation can be represented by just using the f of s basically. All right, it's the same thing there. Okay, so because as you all know, transfer function basically, you know, describe the relation between input and output. So here you can take note that CS there is an output, and RS there is the term to describe the input. So if you simplify the whole thing, you will have CS over RS. So the whole term there can be represented by the GS. So GS basically is a transfer function of the system. Okay. So the same here, you know, describing the GS as a system transfer function, taking RS as the input and CS as the output. So you can see how this thing happened. And GS basically in this case is an open loop transfer function. So you have to know this. Okay, so you will basically see various kind of transfer function. If you happen to see one, this is how you get to know the term that they are using. For example, there will be question asking, you know, if you look at any transfer function, what is the order of the transfer function? So you have to look denominator and look at the highest power of the first S, right? That's the order. And then you will have to know which one is the zero and which one is the pole, all right? And from here, there are the example here of how you should extract the pole and zero. Okay, this is more or less this is the first order system, and now this is how transfer function of the second order system. Okay, just now we have seen transfer function for an open loop system, but now this is how you get for the closed loop system. Okay, so you can see for the whole equation, E of S is basically RS minus C of S multiplied by H of S, basically, because you have input signal. If you look at this block diagram, you can start from the HS. The input is CS. Then the output of HS here is basically CS times HS, H of S. So in order for you to get the new term E of S there, so you have to take the R of S and minus H of S times C of S, and then in order for you to get the C of S, so you will have the signal of G of S multiplied by the input signal just now, E of S, and when you do substitution, you will have basically the transfer function is taking this form in the dotted red dotted square box. All right. So with regard to the closed loop system, basically also called as a feedback system. These are the effect of things happen when you are working with the system with a feedback effect. All right. Sensitivity, stability, and the gain. All right. Of course, you can when you have feedback system in the closed loop block diagrams. Basically, you can adjust the system stability, you can adjust the system sensitivity, and of course, you can adjust the system gain when you have this thing. All right, you can read on to the detail. Analysis of control system when you are working with any control system, basically you want to know whether this system is okay or not, but how do you know, and how do you check? So first we look at the transient characteristics. Okay, transient response here, they say it's the case where the plant or the system is changing from one steady state to another, and there are changes to the input signal. So this is basically describe the whole operation of a system from one steady state to another steady state, and when the input is changing, how the system is responding. So for example, here the elevator, because the elevator, when you get in, the elevator is in a steady state condition. So when you press your level that you want to go, basically the state is changing from a steady state, and then you have a transient I would say period. Things are changing until you reach your level, then the system is reaching the steady state again, for example. All right, so the response from one state to another is called transient response. And then from a control system as well, you may want to see how stable the system, okay, and of course how the system is responding when it is in a steady state, right? So this graph basically describe many kind of transient response system. There are three different lines that represent three behavior of three different control system. All right. the same thing on the graph. So now we are looking at the design process of any control system. So there are 1, 2, 3, 4, 5, 6, 7, 7 steps that you have to know and you have to be able to do before you can design a complete control system. Okay, the first one there is to determine the physical system requirement. This is specification preparation. Number 2, you have to draw the block diagram. Number 3, you have to go down to the detail for the schematic. And number 4, you'll come up with a mathematical model. Number 5, simplify the model, the block diagram. Number 6, you perform the analysis. And from there only you can build the prototype. All right, so throughout this whole semester, basically you will be learning how to perform this design process. All right, chapter 2 onward, you will be basically moving from one block to another. All right, so I have a couple of examples here. For example, we want to design antenna control system. So basically the first block basically is to determine the physical system from requirement. So you may want to see now what is the power supply, whether this thing has a remote control, what are the costs, you know, what are the basic operation, basic function. This is where you want to you know, collect the information. So this is roughly how the antenna may be looking like. Okay, they have input potentiometer because you want to control the angle of the you know, antenna, and then you want to know whether the antenna is facing the right angle. So you have two things here. You have a potentiometer and you have another potentiometer at the antenna. So this is the basic thing. All right, then from here you draw the basic block diagram of the system. For example, there you have the first input is the angular output. Potentiometer will give you the voltage, and of course, because you have another sensor that tell you whether the antenna is responding to the correct angle or not. So you will have some kind of potentiometer feedback to the sending junction, and from here you have controller and also you know, many other things before you can get the correct angle. All right, so this is basically the basic functional block diagram, and then this is the proper schematics. Okay, also this is another kind of schematic. This is just example for you guys. Then you will have to come up with a mathematical model. We will learn about this in the next few chapter. Okay, we have different mathematical model for different control system. Okay, then this is the analysis part, where you would want to know whether your design is stable or unstable, there's level of sensitivity and many others. And finally, you can start to build your prototype, for example. Okay, ni tak ada apa lah kot. Alright. So I think more or less that's all for this chapter. Thank you.